Everyone, thank you for coming to the session on this beautiful Saturday morning. In our session today, we're going to look at productive struggle in particular, which is getting our students to do more during maths time. So this is something that you might be considering, for example, if your students are over-reliant on you as a teacher, perhaps, or shy away from maths when it is time to actually do some thinking. So I hope during this session, we're going to be thinking about how could we encourage them to develop more productivity and that resiliency that we want them to have during maths time. I'm going to start us off with opening karakia before we begin. Tūtaua mai I runga, tūtaua mai I raro, tūtaua mai I roto, tūtaua mai I waho, kia tau ai te mauri tū, te mauri ora ki te katoa, Haumie, huie, taikie. Tēnā koutou katoa, ko China te whakapaparanga mai, engari ko Aotearoa te whenua tupu, ko Tamaki Makaurau te kāinga, he kaiako OE Cognition Education, ko Heasteen toku whānau, ko Sonja toku ingoa, nō reira tēnā koutou, tēnā koutou, tēnā koutou katoa. Just a little bit of background from me as well. I currently work for Cognition Education, predominantly as a maths consultant and maths facilitator, doing PLD throughout schools across Tamaki Makaurau. And I'm also a part of the programs for students where we do MST and AILA mentoring for schools throughout New Zealand as well. In the past, I was the maths curriculum lead and team lead at Epsom Normal Primary School. You can see my lovely past school whānau there in the corner. I also did my Masters of Education, focusing on the development of mathematical identities with the Auckland University. You can see our lovely pets as well, and my husband with our travels around New Zealand. So coming back to our session around productive struggle. So productive struggle is something that you want to think about if these are any of your students. So for example, in the classroom, you might have your one and done student who answers your question or answers a question on a worksheet or in the problem and then moves on immediately. So the answer is always the focus and our students move on. You might have some students who either sit back and wait, are a bit more reluctant to join in, waiting for others to contribute or answer questions for them. The ones who avoid eye contact, who shy away a bit, this productive struggle session would also be helpful for them. And of course, we also have our dominators who usually dominates the discussion during when we're doing turn and talk. So even though we're trying to get our students to engage and talk more during their math sessions, these sessions seem to be taken over by certain students as well. So the question we're going to be looking at and answering today is, how could we get all our ākonga to engage equitably in productive struggle at maths time? So starting us off, I want you to just take a minute to consider what's something that you've learnt to do, but you weren't very good at initially. And then the biggest question would be then to consider, how did you improve at this thing? So if you feel comfortable to, feel free to contribute in the chat. What is something that you weren't very good at initially? And if you're thinking about it now, how did you improve? An example, and I always think about this, especially when I'm driving around, considering productive struggle, is when I'm driving to new places and I input a destination on my Google Maps, I find that if I'm going to the same place and I'm relying on my Google Maps, so having those instructions said to me at every turn and every corner, whenever I go to that same place again, I find myself still entering that place on my Google Maps and requiring those instructions every time I drive to that place. So even though I've been to that same place perhaps 10 times before, I still need those instructions to do it. However, if I removed Google Maps from the equation, so maybe I used it the first time, and then actually try to identify landmarks when I'm driving to there the next time, I find that I'm much less reliant on those instructions the next time. So it's that improvement around, do I need the constant instructions when I'm driving there, or are there little signposts and landmarks that I could look out for myself? And that's something that always jumps out at me when I think about productive struggle and how it correlates to our maths thinking. So hopefully through that consideration, you identify that perhaps you improve by physically and actually doing something for yourself. And that is a big thing in maths that we want our students to do. So taking the child diving into the pool, for example, how did he get better? So it probably wasn't from listening to a lecture. Probably wasn't from sitting on the sidelines and watching his classmates or peers swim or dive into the pool. Probably not even from watching an expert diver doing it. So the big thing about productive struggle is the child gets better at diving into the pool by physically engaging in that productive struggle. So he will get better from the opportunities that he has to work hard. And of course, while doing that, he is getting that guidance and experience from another, and that's where the teacher comes in. So through all that, consider what is productive struggle. So here is a lovely definition from Boston, Frederick, Margaret, and Stephen. And it talks about how productive struggle is the opportunity for our students to struggle with a challenging task and make sense of a situation. I think that is a very big point, is that we need to provide our students with the opportunity to actually do that without jumping in too soon. So when students are productively struggling, it does not mean that they no longer receive support from the teacher. Okay, so productive struggle is when your students have that opportunity to go have a go at the challenging tasks with the teacher support still there. But the support is to encourage them to persist rather than removing the challenge. And I think that is a big aspect that is quite difficult at maths time, especially around the talk of, oh, we want our students to develop positive mathematical identities. We want our students to love maths. So when something becomes quite challenging, oh no, we jump into that rescue mode and we want to rescue our students from that challenge. However, if we consider our experiences, that challenge is actually the thing that makes the experience a bit more exciting. The challenge is the thing that makes you feel like you've achieved something once you've conquered the challenge. So an important part of that productive struggle is that we don't remove the challenge for the students at maths time, rather we are encouraging and supporting them to continue through that struggle. A big thing around productive struggle as well is there's definitely also unproductive struggle. So differentiating between the two, and it's really about knowing your students. So if you know your students could persist with a bit of encouragement, sit back and let them go through that productive struggle. Of course, if it's unproductive struggle, and we know that when that's happening, children have disengaged, they're not going to attempt it anymore, then that challenge is a bit too hard. So it's about adjusting that and scaffolding that enough for our students to have the challenge without being really stuck in the mud. Productive struggle also gives our students the opportunity to explore a learning experience more in depth and develop their own understanding of something. So often we ask ourselves, and I tell myself this all the time, like we've definitely taught something like place value, again, year after year after year. And by the end of year 5, I go, how come my students still do not remember this? Because I know they've learned it probably from year 3, year 4, year 5. It's definitely been 3 years. It's definitely something our teachers have introduced. They don't remember it. And it happens because when that's happening, students are replicating an idea rather than developing that solid idea of place value for themselves. So thinking about that driving metaphor again, I can get to a location if I'm following the instructions step by steps from Google Maps. But if you remove that, and I've never actually learnt to drive by identifying the location and landmarks for myself, then I definitely would still struggle to drive to that same location. Okay, thinking back to our students who disengage from productive struggle. So these are our students who hide. We want to also have a think about, why do our students usually hide from productive struggle? So our students usually hide for a myriad of reasons. They could hide because they have some maths anxiety. They could hide because they have some low confidence or no sense of self-efficacy during maths time. There could be some trauma in math, something that didn't happen in a good way in the past. Language barrier is definitely a big thing for our students as well, especially since there's so many new words, or words that actually mean the same thing, same or different things when it is in literacy and in maths. And of course, some of our students just don't identify as a maths person, either from their experiences or from things that they have been told. Our students also hide in a myriad of different ways. So it's not just our students who are shying away and not answering those questions at maths time, but of course there's also our students who jump out with behavior problems, or they just answer with silly answers. They decide to be the class clown, maybe they're just guessing. And of course, then we have our students who are slinking down and allowing others to dominate that conversation. And sometimes also with our students who get away with providing us with a closed answer. So just yes, no, or a number, 42, 2, and seeing how we react to that. And of course, we also have our students who need to go to the bathroom or can't find a pencil, who disengage in that way. Okay, and this sort of becomes a bit of a vicious cycle. So we have our students who don't identify as a maths person, which means they don't engage in the lesson. Usually when we go, oh no, my student isn't engaging in the lesson, or it's too difficult, or something's wrong, we then help them to remove the challenge because we don't want them to hate maths. However, when we remove the challenge, it then means that we're oversimplifying the task. And when the task becomes oversimplified, it's boring. And lots of times when maths is seen as a boring subject, and these students, well, it's boring, I don't identify it, it's not something that I'm interested in doing. And it creates a cycle of them saying then, okay, then I don't identify as a maths person. So that's the important bit where we need to consider that productive struggle, because it comes in within that cycle of our students and their mathematical identities. So before we even engage in our productive struggle, some things to talk about, and I believe lots of people are implementing these in their classrooms already, is helping develop that strong maths norm. So that idea around productive struggle is pre-built in our maths classrooms. So these are things like Joe Bowler's maths norms, things like talking to students about that everyone is a mathematician, mistakes are valuable and we can learn from them. How we can have respectful discourse is an important part in that productive struggle, because during this engagement, we want our students to be talking to each other, sharing their ideas and getting comfortable with justifying, whether with drawing pictures or using materials. So it's all about that respectful discourse, and everyone feels comfortable with being able to share their idea. Equitable participation is a big one in the classroom as well. So when students are getting to share their ideas, a lovely way to do it, especially if you're already using things like turn and talk and you're finding some students are still dominating that conversation, to make the talk a bit more equitable, is after you do your turn and talk, students have to share something that someone else shared with them rather than their own idea. That way they still get credited with their idea, but it encourages everyone to be listening and everyone to contribute. And a big one as well is, of course, the no one left behind, is that if we're off doing a group project or working together on a problem, it's important that everyone understands what's happening. So when a task is being set and a justification is required for students to share their answer, it's not usually the student's choice who gets to share back, but someone in the group is going to be told they're going to be sharing back. And for their group to be successful, that person has to be able to share the ideas of the group, which ensures that students are checking everyone in the group understands what is going on, because they don't know who's going to be called on. And of course, using those talk moves to get students to have time to do their thinking. For our students who are more reluctant at sharing their ideas, giving them that opportunity to just be able to repeat an idea. So they don't have to come up with an idea immediately and by themselves. If they agree with something, they could just repeat it, or they could add on. So lots of opportunities for our students to engage in that discussion in the first place, to then lead into that productive struggle later on. So now I'm going to get us all to engage in some productive struggle. In a moment, my lovely co-host will help put us into some breakout rooms. So I think each room we all have 3 to 4 people. Once you're in the room, feel free to unmute yourself and turn on your camera to communicate. And then in 5-10 minutes, we'll come back to this main room to discuss what we've noticed through the productive struggle. So while we're doing this task, I want you to consider, how does this enable productive struggle? Throughout this task, I want you to imagine yourself first as the students. How might you answer these questions and attempt the task? As the student, what is your predominant role while doing this task? And then consider yourself as the role of the teacher. As a teacher walking around with your students engaging in this task, what is your role as the teacher? So before we hop into our rooms, just a little bit of a warm up, and feel free to, again, unmute yourself or type in the chat. What do you notice or wonder about this picture? And this is a lovely activity that comes from a Maths for Love called Prime Climb.
Right, shall I open I'll open the breakout rooms.
Oh, we'll maybe give everyone a minute to see. So if anyone notices anything, type in the chat, or feel free to unmute yourself. What do you notice about the picture that's up at the moment?
Can you see the chat, Sonja? Do you want me to read it out?
Yes, please.
I'll read it out for the recording, actually. One moment. The numbers are coloured by multiples. Green multiples of 3, multiples of 5 are in blue, even numbers are in orange. Prime numbers have full circles.
Excellent. Great observations.
Yes.
Anything else?
Multiples of 3 have some green. Each colour is a multiple. I was wondering about the grey one. Oh, and the 7 grey. Sorry, I can't see it. Yeah, that's the... Oh, hang on. No, why are 1 and 7 different? What's a grey? I don't know what the grey is.
1.
Mixed colours are products of the coloured numbers. 2 times 3 is 6. Nice.
Prime numbers have got full circles.
Yes, absolutely.
Yeah, I guess 1 is special, right?
Yeah, it's always special.
And then we can see something like 8, which has been split into 3 sections, with the orange representing the number 2. So it's actually 2 times 2 times 2.
Ah, clever.
Cool. So with that initial concept there, in our breakout rooms, this is what you will be looking at. Let's see if I want to go to the next slide. There we go. Actually, in the breakout rooms, the coloured ones are still there in the first column. I've just recoloured them slightly because they are Oh, I also need to put the link of the Jamboard, which I'll pop in the chat right now.
Oh, so you would get students to color them in, would you?
Yes. So once you're in your Jamboard, the colors have been rearranged slightly just to match the highlighting colors that are available in the Jamboard. See if you can work with the people in your room to identify maybe what the next few rows, you don't have to do all of them, but just what some of the numbers colors might be. So again, thinking about that productive struggle as a student, what is your role while you're doing this activity? And then consider as the teacher, if you're walking around monitoring the productive struggle in this classroom, what would the role of the teacher be?
Fantastic. Cool. All right. So shall I open up the rooms now so people can join?
Yes, please.
Okay. So there's 4 rooms open. Just jump into a room and we'll have a little kōrero in there. When I went to click that link, it said something about Google having to shut down. So I'm not going to join there, Sonja, just in case I get booted off. Oh, Kimmy's here. Fantastic. So Hayley and Angela, if you jump into a room, and Andrea, if you jump into a room. Otherwise, I'm just going to. I'll just assign some people. Just check no one's in there by themselves.
Yes, that's a good idea.
Room 3, Mrs. You're going to room 3. There you go. Oh, that's good, Sonja. Cool. I like that.
So I guess the big idea is getting people to actually think about, so my students can engage in this task if they know their timetables, but also if they can skip count. So it's actually available to all those students in the classroom and they can engage in different ways. Yeah,
fantastic. Yeah. I was just going to go and give it to my girls. Something Brad's doing a lot of this. You probably weren't in Brad's session, but he's done a lot of Joe Bowler's work and just getting St. Peter's to do all the mind, how to learn, how to remember, how to recall. It's been really good, he said. It's been fantastic. And it's I've got an 11-year-old and an 8-year-old, and I always ask them, what did you learn today in maths? And I'm not getting, and I've just realized I need to push more. And even if it's like, can you show me an example? Because they're not telling me what it is they've learned. They're fudging around what it is they learn. And even to the point where I've had to go, what was it, face, place, and total value again? Like, oh yeah, we did some of that. And no, we did 5-minute magic. But they're not actually telling me what it is mathematically they've learned. So they're not reflecting and recalling what it is. And that's what I'm trying to get out of them, so that they have that recall.
And so are your children in primary?
Yeah, year 6 and year 4.
Would they have the same difficulty recalling a science lesson,
I wonder, exactly. Yes, I know, and I don't ask about science. I probably should.
That's a big thing to have a think about. Do your children, can they recall their science lesson? For example, if they did an experiment, are they able to talk about it? And is it because we don't give them that same sort of exciting experience where they actually so like a lovely example of productive struggle is that science teacher versus maths teacher example, where as a science teacher, you perhaps give your students a bunch of materials, lemons, potatoes, coins, wooden sticks, and you ask them, could you light up this light bulb for me? And your expectation is that they're using those materials to explore and see if they can figure out how to light up the light bulb. Whereas as a math teacher, it's a lot more structured for some reason, we would say, you know, step 1, do this, plug this into the lemon. Step 2, do this.
Right.
And
it's not the explore.
scripted.
They're not having the exploring and talking about number and what goes here, whereas this would be they're exploring. I like that. Yeah, you're right. And I think that's what we miss from a lot of our mathematics lessons. And I'm just, I've got to change. I've got to talk to my girls about that and think about talk to the teachers about it as well.
Mm-hmm.
Kia ora, Mrs. Clee. You're not joined, but I think you probably popped out and then popped back in. So you're just here with us. Is that all right?
Yeah, it's fine. Thank you.
Okay. Sonja, how much longer did you want them to be in there?
I'm just having a look. I think breakout room 4 are really progressing through. Maybe 1 more minute.
I'm just going to move in Angelina to breakout room 4 because she's in there by herself, I think. So I'm just going to move her out because GPS is not joined. And how's Andrea and Morgan getting on? Are they all right?
And on the Jamboard, I don't have anything from 1 or 2 yet, but 4 is getting along very well.
Yeah. Okay. Are you sure you didn't want to join in there, Mrs. Clee? It's fine. They'll be having some good chats and getting to talk to each other, which is always good.
Mm-hmm. And I feel like a nice way to actually get to know an activity, you have to physically do it. Like it's all that someone explains to you what the activity encompasses. But once you've done, you're like, oh my gosh, there's like so much more depth to it.
Oh, absolutely. I think that's the best PD is actually doing a maths problem yourself, isn't it? Because you make so much connections. And I remember Julia and we were at PMA Day, and was it Lisa Dara and Megan Clune did the light bulb problem with the 10 light bulbs and one on, 2, and the factors, and then what's the pattern. And I mean, the 4 of us, it was great working in a group and just seeing. I mean, Julia has always impressed me with how she sets things up in a structure. She's got such a structured mind, whereas I'm a little bit random, and then you see the other groups struggle because how you structure your recording your results allows you to see through the problem often. And I think that's a real skill, is being able to structure how are we going to record this and how will we best show the patterning. It was just really interesting, and it was fascinating. It's a great problem, and problem like these are great. And I think the more of these great problems that we can, this is a great visualization. It's not necessarily a problem, is it? It's a visual that how does it work?
Yeah, so it's sort of going past that. This is a times table, memorize it. It means groups of. You can really see the products and the factors here like quite clearly.
Well, what surprises me is why isn't there 5s? Why isn't there 6s? And then having to think about that, because I would expect there to be 5s, a circle split. Oh, there is a 5, 32. Sorry, my bad. I've just seen it. Fantastic.
There's the 32,
and 64 and 32, 64, and that's a connection as well in itself, the 32 and 64. Fantastic. And also thinking about recalling, does that have a name? Like what the teacher would do is, do we remember the name for that? It has a name. The product I'm thinking of, because when you were using the words and the language, I was thinking, that word product might mean different things to different people. And
yes, absolutely. And that's that vocab coming in for so many of our students as well, because there's that product in multiplication, but then in day-to-day lives, product means a different thing.
That's something you buy at the supermarket, right? Yeah. So Yeah, a homophone. I just learned that word. Thank you. That was a great word. But yeah, that's right. It's like that's the teacher's role, I guess, is there's a word, we've got a word for that, or you guys are using this word. I hear you using this word for that, talking about a product. Do you know its mathematical name? Yeah, cool. That is so cool. Love it.
Wonderful. Shall we bring everyone back now?
Yeah, so do I do a broadcast or just close?
I think if you close rooms, it gives them about 60 seconds.
Yeah, okay. Close all rooms. There we go. So what time check have we got? We got 12:33. So you're running on time?
Yes. We're aiming for 12:45. Is that right?
Yeah, that's right. And I think teachers will really appreciate having a talk and doing and they will want to know, they've already asked, where can you get this problem?
I will share all of it with you, and then when the recording goes out, so the readings, the activities, it will go out.
Perfect. Okay, I knew you would, Sonja. I knew you would. All right, so they're coming back shortly, and you'll do that. Yeah, so that's the thing. It's like teachers, we're gatherers of these types of problems, isn't it? Because it's so rich and it's so visual, and often when they're visual, there's a step in for every student.
Yeah, absolutely. And you can take it in so many directions. For example, instead of just telling students about prime numbers, this way they're actually discovering for themselves what a prime number is. Like, why is it not split into more than into 2 or 3 more pieces? And they discover the process.
Yeah, I'm just wondering, 3747, is that a Mersenne prime? Is that you know how they come in pairs? And the 717, 3747.
3747. So the full circle ones are all primes.
Yeah.
Do come in pairs. Oh, you mean like whether 77 would be one?
Yes. Is it I don't know if I'm saying it correctly. Is it Mersenne primes, which are pairs of primes?
I'm not really sure. Might have to find that out later.
Yeah, I'm just thinking. You see this? No, what's another one? 43 and 53.
43 and 50. Oh, yep. And then 1323.
Yeah.
I think you're confusing Mersenne primes with, there's something else. I'm not remembering the other one. Mersenne primes are the ones that are 2 to a power -1.
Thank you, Cami. Yes.
But then there is a thing about twin primes or something.
Twin primes, yeah.
And those are the primes that are like just 2 away from each other. So like 3 and 5, 5 and 7.
Yeah, 2 away from each other. I was just looking at I just noticed the 23, yeah, they're underneath each other and what's going on there. So it's 2 away from each other, right? Yeah, thank you.
Because that 57 isn't prime, so that's why that's got 2 bits in it.
Yeah, no, the 3747. Yeah.
Oh, okay.
And the 717 and the 1323. Yeah, but you're right, Cami, it's 2 away from each other. They're the special ones. They're the twins, aren't they? Yeah, that's right. And Mersenne is a power. Yeah. Cool, thanks. All right. Everyone's back in, I think. Although
yes.
I think I've got 14. I think people might have dropped off. But anyway, keep going, Sonja. Someone's raised their hand.
Sorry. Yes, sorry. I just wondering how are we determining the colors of the prime numbers?
Oh, so we're determining what the colors of all the different circles might be. So I've had students do this in lots of different ways. So it's a nice way to explore a lot of different things, actually, depending on where you want to take the lesson. So the predominant idea is that the circles show the different numbers that multiply together that make that number. But I've had students who have done, they've identified that if you skip count in 2s, all of them would have a part that would be orange. So even if your students are just working with skip counting, they can go 2, 4, 6, 8 and go through the process and identify that each of those will have at least one orange bit, and then skip counting in 3s and identifying all the numbers that would at least all have one green bit, and then same thing with 5, 7s and so on. which then leads into that knowledge around their times tables and what happens when we multiply those numbers together, and how we can make lots of different numbers. Once they've gone through that process, and they start noticing actually, sort of like that discussion we had right at the start, the ones that are full circles, we've never put a color on them. And then that discussion pops in around, okay, should we assign them a color? Perhaps we could assign them a color red, and that discussion of why do you think they're all red? And then it's almost that discovery process. So rather than directly telling our students, prime numbers are numbers that can only be multiplied by 1 in itself, they're discovering, oh, when I've skip counted or multiplied in 2, I've never reached any of these numbers. Neither have I reached it when I did it with 3s or 5s and 7. So it's that discovery process. I go, actually, maybe these numbers can only be multiplied by 1 in itself. And therefore we've assigned it the color red, and therefore it is a prime number. And that was a bit of that discussion that Anne and I actually had while you were all in breakout rooms around that concept behind the science teacher and the maths teacher. As the science teacher, we so often give our students all these different materials and we ask them to explore. Here's all these different things on the table. See if you can light this light bulb for me. And they're doing that through an exploration process. And at the end of the lesson, we go, wonderful. What did you discover about lighting the light bulb? What materials did you need? How did you do it? Whereas as maths teachers, so often we do it the complete opposite way around. We say, today we're lighting a light bulb. Here's how to do it step by step. Now follow my instructions and see if you can do it following it step by step, which again takes away that discovery and that productive struggle student for us, for our students during math time, and perhaps would then lead to that, because Anne was talking about how her children can't quite remember their maths lessons, and I was quite interested in finding out whether they would remember their science lessons, and if that was the factor that was missing, that discovery and that challenge and that productive struggle part. And so moving forward, so the PowerPoints, the activities, and the reading that'll come after this will all go out to you. So it'll all be here. So here's just the reveal of what the colors and the answers are. And you can see that some of the red actually comes in because those prime numbers later on help us make some of those other numbers. Slide remove, here we go. So thinking about our productive struggle, I hope you had a chance to have a think about what you as the role of a student would be doing in this task, what you in the role of a teacher would be doing in this task, and how this task enables that productive struggle. So this task is quite actually rich and in depth. Like we said, you could use it to explore a lot of other areas, but it also has that low floor, high ceiling. It's not to say that all your tasks need to be low floor, high ceiling to enable that productive struggle. Okay, so although this task is low floor, high ceiling, it's a nice one to do for your whole class, but it's one that really allows your students to justify and explain their thinking. So I think that's where the productive struggle comes in. So when our students are talking about, it's quite overwhelming, especially when you have a full page of blank circles. It's that talk around, okay, I'm looking for those patterns. I know that if I skip count into all of these are orange, and it's that justification that they're giving you, that is the productive struggle that they are going in. And of course, it's that opportunity for them to, if they get stuck, that opportunity for them to explore it themselves a bit more. So as the role of the teacher, if your students are stuck in this problem, the prompt that you might offer them is that initial warm-up that we did. What do you notice? What patterns can you see? What can you tell me about it? So the role of the teacher is predominantly you asking them questions, guiding questions, but asking them to describe their thinking and their ideas. Predominantly, you would absolutely try to hold back and pointing out, skip count in 2s and color these orange. So that's the part that we don't want to tell them. We want to ask them until they discover that pattern for themselves. And then once they discover that first pattern, they go, oh, so these ones are orange. Then you ask them, what do you notice about number 3? What do you notice about number 5? And you actually see it happening in their minds when they make those connections themselves. They go, oh my gosh, these ones are all skip counting in 5s. And you have that moment, almost that light bulb moment that we're looking for in our classroom. where they go from that struggle initially to that guided questioning and thinking to I've discovered how to solve this problem for myself. So never at any point am I going, skip out in 5s, color these ones blue. And then therefore thinking about the role of the student. The role of the student is to do the thinking in maths time. So the role of the student is I'm thinking, I'm justifying, I'm clarifying my ideas and solving this problem, and I'm persisting with it. And of course, doesn't have to apply to just tasks like these, can be applied to lots of other examples as well. So the predominant thing that we want to think about when giving a task to students, any type of task at all, could just be a simple word problem, is the talk time. Okay, how much talk time is you as a teacher talking, and how much talk time is it students talking? Okay, and in this chart we can see that we would predominantly want our teacher talk time as 30% of the time, and our student talk time as 70% of the time. So we want our students to be engaging in that discussion, either with each other or with you as the teacher. Your 30% teacher talk time is you walking around questioning constantly, facilitating that conversation, prompting them when they need a heads up. Whereas in a traditional classroom, it's more of a 90% teacher talk and 10% student, whereas it's more the teacher up front delivering instructions and talking through steps, and students copying and emulating, and that 10% is mostly around answering that question. So why 70-30? So it provides our students with more opportunities for getting feedback. It limits the amount of teaching that teachers do. So teaching as in that I'm just going to stand up the front and tell you what to do step by step sort of thing. So it limits that, but it encourages that interaction between teachers as they are walking around the classroom and promoting that thinking. It promotes fluency among students, so it gets them talking and thinking about their ideas. It allows students to just get to it. Okay, so sometimes we see our students fidgeting on the mat, they're ready to go, they just want to have a go, and giving them tasks like this allows them to have a go and just get to the task. And of course, you will still be facilitating that thinking when your students are engaged in the task already. And of course, it makes our classrooms more student-centered. So in these maths classrooms, our students should be the one doing most of the work, doing most of the thinking, doing most of the talking. So this is a lovely reading. So again, I'll go out with the PowerPoint by Hiroko Washer, who talks about the strategies that we could use to help support that productive struggle. So these are actions that we can take when our students prompt up with, I don't get it, I don't know what to do, or I just know the answer, don't know how to explain it. We get told that so often. Some lovely examples that he gives in the reading, and it comes with a problem. So you can see this is a much more traditional, just a simple word problem, an example of how when we're not facilitating productive struggle, how our questions usually guide students directly to the answer. So our questions are very guiding. And that's one of the big things that pops up as our teacher actions. We need to be very careful with what type of questions we are asking our students when they are engaging in that productive struggle. So instead of guiding questions, we want justifying questions. Instead of telling our students, what do you do next? Could you show me how this might look like as a picture? What do you notice about the problem now? What could we do to compare the two barrels? You're asking your students to come up with a solution with your questions. Another teacher action that he talks about is encouraging our students to reflect on their work and to reflect on their answers, not just about getting the correct answers, but really encouraging that justification. And a big part of that is around practicing our Switzerland face. And that means that we need to be neutral with our emotions, with our face, with our smiles. We need to be interested in what they are saying. Okay, some prompts that we might say would be interesting. Tell me more. Why do you think that? Hold on to that thought. Let's come back, which tells us the idea is important, but we will discuss that more. And something to ask yourself, do they know the answer because they know the answer or because they are reading your face? Because one of it comes up very often, and this happened to me just the other week with a student who was doing a problem, answered incorrectly the first time, attempted it a second time, called out an answer, and immediately the teacher went and gave her a fist bump. And what did that fist bump tell that student? That she got the answer correctly. However, when prompted, I asked the student, so can you tell me, how did you know that? How did you know that answer was correct? Her answer was, because my teacher gave me a fist bump. So therefore, remaining neutral to get your students to justify the idea. Why do you think that? And it's really important to do it both when your students' answers are correct and incorrect, because sometimes that really throws them off. So if you're only asking them to justify their ideas when they're incorrect, then that creates the environment of, oh no, I got the answer wrong. So whether they're correct or incorrect, neutral, justified, wonderful. I loved your explanation after that justifying. So encouraging them to do that justification. Okay, and of course, there's some examples of that within our reading. So getting our students to say, what do you think? Why did you think that? And of course, tell me more. Alongside our talk move strategy was giving students time to actually do that productive struggle. This means that we are not hovering around them when they're doing their main thinking. And a nice way to think of this one is, of course, our spray and walk away. So give them a prompt, give them some information that they need, and while they're thinking, remove yourself from the situation, especially when it's group work time as well, because so often you would find if you're hovering, the students end up turning and directing their answer to you as the teacher rather than discussing and thinking about their ideas as a group. And lastly, we have acknowledgement. So acknowledging that the struggle is important and a part of learning maths. And it's okay to struggle. We all struggle with that thinking. But when we're doing that, we're actually learning it. And finally, just some thoughts around what shuts down our productive struggle in the classroom when we're physically taking the pencil out of their hands. When we break down a task too much, if we're guiding them step by step, then we're shutting down that productive struggle. If we're lowering the cognitive demand of the task, or if we're not giving them enough time or opportunity to make sense of the mathematics. And this is the thing I think mostly, again, with that mathematical identity, we perceive that frustration and we go, okay, we need to rescue them. Okay, if we don't rescue them, they hate maths and I failed as a teacher. So that's incorrect. Don't rescue too soon, okay? Give your students the challenge. It's that challenge that makes them feel successful. Cool, and that leads us coming into the end of our session.